right, guys. So to finish lesson 8.1, open part 2 and get a copy of the blank notes on your screen and open the applet for confidence intervals. Please take your notes, read through the questions 1 through 6 and answer those questions and then press play whenever you are ready to discuss what you saw. Okay, so when you did number 2, you should have seen something that looked like this. So hopefully you have that sketch put into your notes. So my sample of 10, if you'll notice these every single one of these intervals did capture the true population mean mu as indicated by that green line. So and you can also see it down here, it said 100% of the intervals captured the true mean. So then, as you went through 3, 4, 5, and 6, you were able to make some generalizations about the changes you could make to a confidence interval. So, if you took from 10 confidence interval and actually went to 100 confidence intervals, you should not have been shocked to see that the number of intervals that actually captured the true mean was around 95%. Then, number 4, when you increased your confidence level from 95 to 99%, your intervals got wider. You should have seen the horizontal line get longer. So, as you increase your confidence level, the interval gets wider because we want to be more confident that we're going to capture the true mean. So, it's going to hit mu more often. So, as you increase your confidence, you increase the width of the confidence interval. So, that is that's like there's this cute cartoon in your textbook. It's on page 473. It's a Garfield cartoon. It says, from the television, Garfield's watching TV. Taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above. So then Garfield said, this guy's never wrong. So if a forecaster said, okay, the temperature is going to be between 0 and 200 with 100% confidence, obviously he can be right, but he had to make a super wide confidence interval to be sure to capture the true temperature for tomorrow. So if you increase your confidence level, your width of your confidence interval is going to get wider. So then if we decrease our confidence level, so we went from 95 to 99, now down to 80, you should see about 80% of the intervals that were drawn in your applet actually did capture the true mean. So here is the interpretation for a confidence level. If we make many, 80% confidence intervals, we expect about 80% of those intervals to capture the true mean. That's what that 80% means. That's what the percent for your confidence interval actually means, is that if we were to create confidence intervals many times, then 80% of those intervals would capture the true mean. Again, like we said yesterday or in the earlier video, it doesn't mean this is the probability of your interval capturing the mean. That's saying if we did I mean, ideally we could do all the confidence intervals, sampling distribution, 80% of those confidence intervals would capture the mean. So then you are also to investigate how your sample size affects the confidence interval. So the sample size going up is going to decrease the variability, which gives us a smaller standard deviation. So as sample size increases, the width of the confidence interval will also decrease. So the three things that I hope that applet made clear to you is what it means to have a confidence level. So if we make many, whatever percent we're interested in confidence intervals, we expect about that percent to capture the true parameter. So what will change our margin of error? Because remember, when we write a confidence interval, it's going to be your parameter plus or minus your margin of error. So if your confidence is increasing, then your margin of error has to increase. That's what makes the confidence interval wider. As the sample size increases, the margin of error decreases. Remember, in your margin of error, you do your critical value times your standard deviation or your standard error, since we're using the sample to estimate the standard deviation. We won't know the true standard deviation because we don't have all the data. But anyway, as the sample size increases, your standard deviation decreases, which is going to make your margin of error decrease. So obviously, more is better. So, but also remember your margin of error never ever accounts for bias. If you screw up how you collect your data, it doesn't matter how good your data is if your data is flawed from the beginning. So here's the check your understanding. If you'll press pause and try to see if you have actually understood what we have talked about and what you explored in your applet, and then press play when you're ready to see if you're right. Okay, so to interpret the confidence level, if we make many 90% confidence intervals, about 90% of them will capture the true mean GPA. So if we were to increase it to 99%, it would widen the interval because the margin of error is going to increase. So how would a 90% confidence interval based on a sample size of 200 compare to the original 90% interval? It would be more narrow because an increase in sample size will decrease the margin of error. Describe any describe one potential source of bias. So there could be some response bias. So yes, we're flashing back to chapter 4. Since the survey was not anonymous, the students may not tell the truth about their GPA. So it doesn't matter how beautiful your interval is, this bias is going to cause your interval to be flawed from the get-go. Now, a lot of students get mixed up between confidence interval interpretation and confidence level interpretation. So on page 474 in my textbook, I have an AP exam common error that I want to read to you. There also on page 474 in your textbook are the definitions in the yellow box about interpreting confidence levels and confidence intervals. But this is an AP exam common error. Many students confuse interpreting confidence levels with interpreting confidence intervals. Every time students construct a confidence interval, they are expected to interpret the interval they calculated. Did you hear that? Every time you construct a confidence interval. They are only expected to interpret the confidence level when they are specifically asked to do so. Now, this tends to show up in multiple choice. Now, I have seen it in some free response questions, but not as often as interpreting confidence interval. So, usually, if you're asked to do something with confidence level, like explain what it means, you'll probably be picking a multiple choice answer with the correct interpretation of level. So, a good interpretation of confidence level will not include the endpoints of the specific interval. You are just explaining what the percent means. In fact, students can interpret the confidence level before the data is even obtained, since our confidence is in the method, not in the actual interval, which again circles back around to this number. This percent is not a probability, it's the number of intervals. If we were to do many intervals, the proportion of the intervals that capture the true mean. So again, maybe we'll get our t-shirt with many on it to help you remember. This is another scenario where we are looking at doing something multiple times and that giving us meaning. All right. See you soon.